So back at this old house talking about wiring. And of course, one of the first things you need to do is locate where all of your outlets and switches and lights are going to be. And you have to take into consideration, even though this is an extensive remodel by one definition, this is also new construction by another definition. The permit that I've drawn is for repair and replacement. So, and I've met the inspector. He inspected the pole building, and I gave him a tour of the house. He loves old houses, so we hit it off. And but still, the question remains is whether or not they're going to consider this completely new construction or just a remodel, because then the inspection standards might be a little bit different. So there is a National Electric Code, which is actually published not by the electricians but by the firefighters, because they don't want the house to burn down due to an electrical problem. So as I say, one of the first things I need to determine is where I'm going to locate the outlets and the switches, and the lights. The lights, of course, will be in the ceiling unless I choose to do some wall-mounted sconces somewhere. The switches are typically going to be 4 to 4.5 feet above the floor, although there is no strict code for that. The outlets generally 15, 18, 20 inches above the floor. One of the old electrician's tips is if you have a hammer, use the hammer as the height guide for your outlets on the wall. And of course, depending upon what room, of course, will determine where the outlets go. This particular box that I'm looking at happens to be in the kitchen space. So it has to be above the backsplash of the kitchen counter, which this height is. The other thing is, as I say, the National Electric Code, has all kinds of requirements. So you got to have an outlet, every 48 inches. It's got to be above the backsplash. In some instances, they're requiring 20 amp circuits. Your refrigerator requires a dedicated circuit. The difference between a 15 amp and a 20 amp circuit is the 15 amp circuits you can wire with 14 gauge wire, which is less expensive than 12 gauge wire. The 20 amp circuit is going to require the 12 gauge wire, which is obviously more expensive than the 14 gauge wire. 14 gauge is also a little easier to work with because the diameter of the wire is smaller than the 12, and so that's also a consideration. Number of circuits per room, bathrooms. Oddly, an anachronism, the dining room requires at least one 20 amp outlet because somebody might plug in a toaster oven in the dining room. Now, I won't be doing any of that nonsense as far as plugging in appliances, but the code has to be considered when all of this goes in. Now, what we see on the box is I have the stud here, and the box is nailed to the stud. And that's not a problem because the boxes all come with little ribs on them that space them out from the face of the stud to allow for a 1/2 inch of drywall to be installed, giving the box the proper recess for the outlet or switch, and then the faceplate accordingly. So that's not an issue in this room here, which is the kitchen space. So the kitchen has a floor, and because this floor was painted, this was probably the finished floor when the house was built. And they would have used a piece of linoleum. They might have painted the design into the floor. I don't see any evidence of that. But this is actually not the subfloor. I've come to the conclusion that this was the actual floor that people walked upon. It was painted. It may have had a piece of linoleum or oilcloth on it. And but I'm now considering this the subfloor because on top of this will go some cement board, as you see in the powder room, and then the ceramic tile will go on top of that. I have enough ceramic tile. It was given to me. They are, I think, 9-inch squares to do both the powder room and the kitchen. So what we have on the interior wall, where this box is located on this interior stud, is the what I'm going to call the subfloor. It goes right to the plate at the bottom. There wasn't a plate at the bottom. I've merely filled in the space here at the bottom with some blocking. So the floor can go right to the wall when it's finished with drywall, and the drywall can go right to this stud, and the box will be in its correct location. So it's an interior wall without a finished floor, so everything is hunky-dory. The drywall can be applied directly to the stud, and the finished floor could be applied directly to what I'm calling now the subfloor. That's one situation. Another situation is where I have in the kitchen as well, I have the subfloor, and I have an exterior wall, not an interior wall. So this wall, you see I've got a 2x2 at the bottom, because this wall is going to be padded out. And the reason for that is because I'm going to put extra insulation in the wall cavity. And even though this wall abuts the porch, I'm considering this wall an exterior wall. So this is my second situation where I don't have a finished floor, but I do have an exterior wall, so it needs to be padded out. So the 2x2 at the bottom, there will be an additional 2x on the face of every stud, so that will give me my depth for the insulation and for the drywall. Actually, I just made a mistake there. That's there won't be a stud here because actually I'm going to have 2 inches of foam in here, rigid foam board, and then an inch of rigid foam board across the face, and then a 1/2 inch left over on that 2x2 at the bottom on which the drywall will sit. So that's the exterior wall without a finished floor. My other issue was I have a exterior wall with a finished floor. And when I was looking at this finished floor here, you can see that originally there was quite a gap between the edge of the finished floor and the stud. And I wasn't sure why that gap was so great, because they had plaster on, lathering plaster on the wall, but that might have been only maybe 3/4 to an inch thick, and then they had an inch of baseboard, but that still would not have allowed the baseboard to cover the edge of the finished floor. So there was a loose floorboard over at the edge here, and I picked it up, and underneath it's painted. So like the old kitchen floor is painted. So I am thinking that this finished floor was actually installed after the house was built, and that would account for some oddities, like here in the living room, where the finished floor has a big old notch in it there, and that's probably because that's where the mantle was. So the mantle was installed on the floor below, which I think may have been the floor upon which people walked, and then later on this nice pine floor was installed, and they just notched around the existing mantle. So, and I see that elsewhere in the house with the finished floors, both on the first floor and the second floor. So again, the issue is getting as much insulation into these walls as possible. So what I'm going to do on a room with an exterior wall and a finished floor is similar to what I'm going to do with a room that has an unfinished floor and an exterior wall. So what's going to happen is all of the stud cavities will get a 1x2 installed against the clapboards. So now what I've done is I've created an airspace here between the clapboards and what will be 2 inches of polyisocyanurate rigid foam insulation. And I happen to have a scrap of that here. So what'll occur is the rigid foam board with the foil facing the clapboards will be installed across the stud cavity here. This will be glued. The 1x2 will be nailed to the stud, and then the rigid foam board will be glued to the 1x2. So that'll be 2 inches of insulation and 1.5 inches of an air gap. One of the reasons these clapboards have survived was because they could breathe. There was no insulation in this house. So that's why the clapboards are still relatively intact. And they'll get, where there are some cracks in the nail holes from the shingles, that'll all get filled, and of course it'll be painted, primed and painted on the outside. So that'll help. But again, for all the exterior walls, we'll get the 1x2 in the stud cavity, to be one on each side, and then the 2 inches of the polyiso insulation, and then across the 2 inches of the polyiso insulation. I don't know if this is going to stay in place, but let's say it does. Okay, so across that polyiso 2 inches will be an inch, an additional inch of the polyiso that'll go across the face of the studs and leave me a little 1/2 inch ledge upon which the drywall will sit. So that'll give me a nice insulated wall with an R value of close to 21, which is a lot more than you would typically get in a 2x4 wall. So, and then of course the 2x2 at the bottom will bring the wall much closer to the edge of the finished floor, and then I will be able to put a baseboard on that'll cover that. So that was the exterior wall in a room with a finished floor, and this is an interior wall with a room with a finished floor. Likewise, you can see the space between the original stud and the finished floor is 2 inches, so I couldn't just put drywall on the stud. So again, I put down the 2x2, but this wall is an interior wall, so it's not going to be insulated. So I have to pad out each and every stud with a 2x2. So that's what I've done here. So as you can see, so this interior wall, each face of each stud has been padded out with a nominally 2x2 piece of wood, so that the drywall can then be attached to it. There won't be any insulation in this wall because it's an interior wall. But again, I needed to get the drywall out far enough so that when a baseboard is applied, I don't have a gap between the finished floor and the wall. So that's going to work out okay. It took me a day to rip 2x, because this is a 9-foot ceiling, 8-foot pieces wouldn't work. I had to get 10-foot pieces, so it would give me a single piece. So it took me a day to rip about 40 2x4s down to what I needed to get the 2x2s and the 1x2s, and then a day to cut them and put them in place. So not too long. That's the first floor, which is almost done, and then I've got to do the same thing for the second floor. So hopefully that'll all get done next week. And of course, I have to do all of this before I can get back to locating my electrical boxes. So for example, here is an electrical box for an outlet in the dining room that I have attached to the padded out stud. So again, at the finished floor, you see when the drywall goes on, I'll have virtually no gap between the finished floor and the wall. I'll have the box at the correct recess. So obviously if I had put the box way back here, and I would not have been able to effectively mount it and mount the receptacle in the outlet box and have it function and look properly and pass inspection and all that stuff. So again, in those locations on an exterior wall where I'm going to locate an outlet or a switch, I will put a piece of wood on the face of the stud in order to attach the box. So in a few places around the walls, that 1 inch thick foam won't be continuous. It'll be interrupted by that piece of wood, but that I don't think is going to be an issue because I have to have outlets and switches and so forth. So that's what's going to happen with the studs and the framing and the blocking before I can get my outlets. But as I say, I should have all of that complete by next week. So a bit of a chore, but something that can be done successfully as long as I memorize in each room what the National Electric Code requires for the number of circuits, dedicated, 15 amp, 20 amp, location, etc., etc. So, but I'll get that. I'll have the computer here hooked up on Monday, so I'll have a ready reference for the NEC code and YouTube, so I can reference things fairly easily. The porch, I have located the leftover tongue and groove. Some of them I have primed and installed The others are waiting because this outside wall is going to get insulated. And I've got to do a couple of outlets here also. But all of these little boards, they've been sanded. They'll get primed, maybe next week. And then once the wiring is done and it has been inspected, then I'll be able to insulate and finish these. Again, the tongue and groove board is going to be like a wainscoting. And it'll be drywall above, and including the ceiling will be drywall. So I'll have a nice clean wall set up here. The J-channel around the window here is thick enough that I can do 2 thicknesses of drywall against this back wall here. So, and then of course I'll trim everything out. Now these windows were not new construction windows, they are replacement windows, so they were designed to go in an existing jamb. I didn't have an existing jamb. I took the old windows out intact, including their jambs. And so what will happen here is these windows are flush to the outside, and then the trim is attached. So here on the inside, what I'll do is I'll use some backer rod in the gaps, and then use some minimally expanding foam, and bring that out to the face of the vinyl frame here. And then since I've got some depth here to make up for with the trim, I'll make a frame that has a right angle all the way around it, and then I will drop that in place. So it's easy enough to make a pseudo jamb extension, and after the drywall, so it'll look quite nice when it's finished. So that's the situation on the porch. So not much activity in the way of wiring. As I say, I've got to get all that blocking and framing and so forth out of the way first, but once I do, and I get all of the boxes located for the switches and the receptacles and the lights, then I can go to town with the wiring. So that'll probably be a video a few weeks from now, and hopefully before the end of the month, or by the end of the month, that'll all be complete, and then I can get an inspection for both plumbing and electric. And then I've already got my HVAC ordered, and that'll go in after the wiring. And then after that, it's insulation and drywall. So nothing much looks like has happened, but actually a lot has happened, and it's one of those things, it's like painting. It's 90% preparation and 10% application. So once the wiring is done, the plumbing is done, the insulation is done, and I'll do the insulation myself, but I'll have a contractor do the drywall because it's just a lot of heavy work. But once the drywall goes in, then the house starts to look like a house. After the drywall has been finished, as far as the joint compound is concerned and primed, then I will sand the finished floors. And after the finished floors have been sanded, then I'll move the furniture in, because at that point I'm going to be pretty much dust free, and I'll get some cabinets and do my kitchen. There is one other project that I'm going to describe in the next video, so stay tuned.